Welcome students. In the last lecture we have studied the atomic structure where we have studied the Planck's quantum theory of radiation and the photoelectric effect. Now in this lecture we are going to study the Compton effect. Now if you see here, the scientist A.H. Compton has given one more proof to the quantum or photon theory. Now according to him, when X-rays of wavelength lambda struck a sample of graphite, an electron was ejected and the X-rays scattered at an angle of theta had longer wavelength. Now this can be explained with the help of this diagram. So you can see here, when incident X-rays that strike on graphite sample. Now if you see here, the electron, no doubt it is scattered, and if you see here, this is the scattered electron, and if you see here another, whatever the electron that is scattered is having certain wavelength, but the emerged ray are scattered at an angle of theta, and that emerged X-ray has a longer wavelength, that is lambda plus d lambda. So you can see clearly in the diagram. Now he has explained this phenomenon of this effect, that is, according to Compton, it was like a ball hitting a stationary ball which is pushed away while the energy of the striking ball decreases. So you can observe in our day-to-day life, that is, a stationary ball, when we hit, then that is pushed away while the energy of striking ball is decreasing. So you can have this example. Now he also visualized that light, a photon of incident light struck a stationary electron in graphite, lost some energy which increases the wavelength. Also, Compton observed that this process could not have occurred unless light radiation consisted of particles of photons. So, by assuming photon-electron collision to be perfectly elastic, Compton found that the shift in wavelength d lambda was given by the equation, that is d lambda is equal to 2h upon mc sine square theta by 2, where h is Planck's constant, this m is the mass of an electron, the c is the velocity of light, and theta is the angle of scattering. So the expression shows that d lambda is independent of the nature of substance and wavelength of incident radiation. Given the wavelength of a photon, one can calculate the momentum of the electron which is ejected. Now the next article, de Broglie's hypothesis. Now this hypothesis is based on the Planck's quantum theory and Einstein's theory of relativity that we have studied earlier. He derived a relationship between the magnitude of the wavelength associated with the mass m of a moving body and its velocity. So we know that according to Planck, the photon energy E can be given as E is equal to h nu. Now where this h is the Planck's constant, nu is the frequency of radiation. Now again, according to the Einstein's mass energy relation, that is very famous relation, E is equal to mc square, where m is mass of photon and c is the velocity of radiation. Now if you see the two equations, you can have the left hand sides equal. So from 1 and 2 we may write the equation, that is h nu is equal to mc square. Again, we know that whatever the nu that is there in this equation, by equating the two equations, that nu is nothing but c divided by lambda. Now if you substitute the value of nu in this equation, then you will get the value, that is hc divided by lambda is equal to mc square. Again, if you simplify this, then you will get this c and this c will get cancelled, and here only one c will remain, that is mc is equal to h upon lambda. So we will call this as equation number 3. Now you can see here, what is this m? M is nothing but the mass of electron. This c is the velocity of electron, and h is a constant, and this lambda is nothing but the wavelength. Now mass into velocity, that we know that it is nothing but the momentum, which is denoted by p, that will be equal to h upon wavelength. Now if I want to remove this sign, and I can express the above equation in terms of proportionality, that is p, that is momentum, is inversely proportional, because h is constant, that is it is inversely proportional to the wavelength. And this equation, or the previous equation 3, is called the de Broglie equation, and it may be stated, or it may be put in words as: the momentum of a particle in motion is inversely proportional to wavelength, where h being the constant of proportionality. So the wavelength of wave associated with a moving material particle is called as the de Broglie's wavelength. The de Broglie equation is true for all particles, but it is only with very small particles such as electrons that the wavelength aspect is of any significance. Now if we consider the large particles in motion which possess the wavelength, it is not measurable and observable. Means this de Broglie equation is in terms of the small particles such as electrons. So everything in nature possesses both properties of particles and also the properties of waves. So we are having that de Broglie's equation, that is h is equal to m upon v. Lambda is equal to h upon mv. So we will see the problem which can be asked on the de Broglie equation. So here one problem is there. Calculate the wavelength of an alpha particle having mass 8.6 into 10 raised to power minus 27 kilogram, moving with a speed of 10 raised to power 5 centimeter per second. And here the value of h, that is Planck's constant, is given, that is 6.626 into 10 raised to power minus 34 kilogram meter square per second. So now let us see how this problem can be solved. So we will write here first of all the given values which are given in the equation. That is h is given, then mass is given, mass of moving particle, that is 8.6 into 10 raised to power minus 27, and the velocity is given, that velocity is, or speed is 10 raised to power 5 centimeter per second. So this value is not in SI unit as compared to the two values which are given in SI units. So we have to convert this value into meter per second, that is centimeter can be converted into meter. So we will get here the value of velocity as 1 into 10 raised to power 3 meter per second. Now the only thing that we have asked in the problem is to calculate the wavelength which is associated with the particle. So using the de Broglie equation, lambda is equal to h upon mv, we can calculate the value of lambda. So if you substitute the value for h, then m and v, the value comes out to be lambda is equal to 0.7704 into 10 raised to power minus 10 meters.